So why don't you just introduce, sorry.
All right.
Are you ready, Renee? Okay, so we're doing page 206, the explore problem, and Mr. Roy has the floor.
All right. So I started off by making a table, as you can see. And when you read the problem, you realize that the cost values don't really mean anything, so you just kind of disregard those. And then I put that into equations, so you had 0.2x plus 0.25y has to be less than or equal to 240, and that was the hours. And then I moved that around a little bit and got that to have a full 1y value, so that, I don't know if you can see it, so that y would be less than or equal to negative 0.8x plus 960. So I multiplied it by 4. And then I did the same thing with the number, so that the X pizzas and the Y pizzas had to be, I think that was it,
Greater than.
greater than or equal to 1,000 pizzas altogether. And then you knew that X had to be greater than 0, and so did Y. So then to graph it, I did a scale of 50. And the first one was pretty easy to do because it went along with the scale well. But to graph y is less than or equal to negative 0.8x plus 960, I went up to 960 and started, and then I thought that 0.8x is also 8 over 10, so I went down 8 and over 10 because it's a negative slope, and that's what I did to graph it. And then you knew the less than or equal to, so this is at the area that
Yeah,
they go together.
yeah, that's exactly right. And I mean, I graphed it in a slightly different method, but, you know, it's good to
Yeah.
hear multiple point.
I wasn't sure how to graph the negative 0.8x.
Okay, and that was fine, and I just wanted people to see what his graph was and how he went about doing it. Kristen?
Well, this is add-on to graphing 0.8. What I learned how to do is, basically what he did 0.2x plus 0.25y is less than or equal to 240. What I did is I plugged 0 in for y to get the x coordinate, and that came out to be like 1200, I think.
Can you show us that? Do you have your work out?
I can do it on the board, but I don't
Okay,
have it all
that'd be
together.
great. Thank you, Adam. Adam, sorry.
No,
Bradley. Yep,
That's my brother.
I know, sorry. Kristen, would you mind just showing how you did that? Write your equations on the board?
Okay. Sure.
Sorry. The way Brad did it was great, and I like that you thought about, where am I? I'm looking for a marker. I like that you thought of 8/10 as 8 over 10. The problem is that scale of 50 was kind of hard to be pretty precise with that. So if you can do this in the light, because we're taping. Do you need a copy of the equations?
Negative 8 over 10.
Well,
Yeah.
no, I can just do this.
Okay.
No, so I had a scale of 50. So it would be down.
How are you supposed to know which one's the x-axis and which
Okay,
one's-
I'll answer that question in a second, Eli.
So basically, I just blanked that out because I plugged it in for 0, and so I solved for x.
What?
And then so x would equal 1200.
So, okay, so I'm not sure I understand what you did. Did you say y was equal to 0?
Yeah, and so when you multiply it, it goes away.
Okay, so I don't think I heard that.
Oh,
Okay, so what she did was she just said, well, what happens if y is equal to 0? If y is 0, and think about this, then you're graphing. I have another marker here. May I share your marker a second? So when I'm going to say let y equal 0, so then all she has left is 0.2x is less than or equal to 240, and then she's going to solve that x is 1200. So when y is 0, I know that x is going to be here. So I have 1 point to graph. Then what do I do?
then you just plug 0 in for x and you solve for y. So you would just plug the
So could you just rewrite the equation?
Which
so
one
that
is this?
This is the equation for the hours. So it's 0.2x plus 0.2y is less than or equal to 240. So to graph it easily, since it's in standard form,
Isn't that what he already showed us how to do?
he did it in a
That
little
was an
bit different.
interpretation.
He had a different approach.
Oh, okay.
That's all, and Christian is
put
just
his name
showing it
small
to you.
things up.
Yeah, so Christian just said, well, when this is 0, so when x is 0, I know that y is going to be 960. I can then, do you have the marker?
Right there.
Oh, there it is, thank you. So I know that I have 960. Is that the graph of that equation?
Yeah.
So it's very easy to graph these if you think about just setting one of your values to 0 and then solving for the other one. Okay? So in this case, we knew, were these going to be greater, or is this above or below? Below. Okay. So I have the rest of the problem done for you, and I'm going to just show you what I have. Eraser. Jeez, I don't know what everything's doing down here. Okay, so for my second equation, let me see. So from the first equation, I graphed x plus y is greater than or equal to 1,000. I said let x equals 0. So if this is 0, what do I know y is going to be? 1,000. Okay, so I go back, and when x is 0, I have y is 1,000. I plot my point, and then I come back and I finish the equation. Let y equal 0, and then x is 1,000. And let's see if I can zoom out. So when x is 1,000, y is 0, I connect my points, and I can see that this is going to be greater than. So this is the area, that's my feasibility region. Okay, does that make sense to you in terms of how to graph it?
Yeah.
Okay, does anybody else have any questions about the graphing? Because now we're going to go on to answer the other questions. Eli?
So there's like two ways you could graph it. You could either do y equals mx plus b or just like solve for 0.
Yeah.
Solve for
I mean, in terms of the scale, it's a lot, you know, like I counted by 50 as well. You know, it's harder to do a slope of 8/10. I mean, you know, I didn't look carefully at Bradley's, but I'm guessing that there's a little bit more error in his,
I guarantee it.
yeah. Michael?
Isn't pizza spelled wrong?
Yes, sorry. Okay?
This isn't
Thank
English,
you.
Michael, this is math.
Pizzas, right. Pizzas, yes, no I in there. Okay, so is everybody good with that?
Right there.
All right, so let's go to the next question, which was about finding the vertices. Can you just wait 1 minute? Okay. Okay, so I'm up to number 3 now. You with me, Eli? Okay, so the next question is, find the coordinates of the feasibility region described by the constraints in step 1. So we know, and I didn't shade this in, but we know that we're looking in this area right here, and I want to know where this point is. You see that? I want to know what the boundaries are. These two were pretty easy because I had solved on the bottom. I know that I have a constraint here when x is 1,000, y is 0, and I know that when x is 1,200, y is 0. But this one is not as easy to identify. How do I identify that point? Because no, we're not guessing here, okay? Because our graphs may not necessarily be accurate. Okay, there's error oftentimes, you know, in graph. And I mean, I did a pretty good job, but I know what happened here was I had to graph 960. I knew this was 900, I knew that this is 950, well, it's sort of there,
It's gonna be a
960.
fifth above that line.
Okay, so how do I know what that point really is?
Calculator.
How? Stephen?
Second trace.
No?
Do you mean using mathematics or using?
Yes, algebraically.
Well, you would, 1 second. Oh,
Let's go back to what do we know? Kayla? What are you thinking?
Elimination, substitution for equation.
Yeah. Do we have, how many variables do we have there?
2.
We've got
I was
2.
thinking-
Do you think that maybe we could rearrange it and solve for 1? Could I say, and I'm going to set this up as x plus y, I'm going to set it up as an equality, is 1,000. Could I say, well, gee. Yes? Okay, so please do that. I'm asking you at this point to plug in, I know that y is 1,000 minus x, and where can I put that? Could I plug that into my other equation?
Yeah.
Yes.
Okay, so just for the record, I want you to know that when I did the problem, I multiplied by 10 just to get rid of that decimal, but it didn't really buy me much, so you can use either one. So if I have y is equal to 1,000 minus x,
Wait, put the slide up.